This is another effort within the 5G-MAG reference tools. It's a bit different in that, sorry, I need to click here, I think. Yeah. In that it covers 5G broadcast, which is a thing that has two major design goals. One is that it wants to allow broadcast network operators to directly reach mobile phones. It should work in the broadcast spectrum. And the second big point is it should stay hardware compatible with existing 5G or 4G modems in phones. So it's a bit different from what we heard before, that now this is about BNOs. It's about broadcast network operators and using their infrastructure to transfer the, video or data, and not MNOs. Okay, so looking at what we start out with, if we want to keep the phone the same as possible, this is what we have, MNO network and the phone connected to it. And this is what broadcast network operators like, big sticks on mountains. So the question is, how do we get from one to the other? And the basis of the whole thing, again, is 3GPP, which defines cellular text standards. And communicating two ways with the base station, it's only going to work short distance, and the phone's transmission power is pretty much going to be the limit of how far away you can get from that base station. On the right-hand side, we have a very different animal. We have one-way communication, because we're never going to reach the top of that mountain there with our mobile phone. And we have to go long distance. And to make that work, 3GPP has defined a standard, or has included features in its standards, I should say, that make this possible. The whole thing is based on eMBMS, which was still something that targets MNOs. So it allows multicast subframes shared between cells in LTE. And based on that, new numerologies were added. So new subcarrier spacing, new CP lengths, that make the whole framing suitable for broadcast, either high power, or low power, low tower, and everything in between. Because we want big intersite distances, it now can go up to 100 kilometers between your transmitter sites. And we also want high mobility and flexibility between the two. And it has to work in receive-only mode, as we said. It needs to stay compatible with the existing modems, which it does by just reusing the LTE framing. It inherits everything that's already in LTE, so you can flexibly allocate bandwidth. And since it's on the LTE physical layer, this is also known as LTE-based terrestrial broadcast. So the 5G can be a bit confusing in the title there. It's the LTE waveform that we're working with. Okay, and to repeat, because this is often a source of confusion, it's a broadcast standard. It's not for MNOs, and it's not a cell-based station, but it's really existing broadcast towers transmitting in a way that phones are going to understand. Okay, so looking at the whole setup, we have a content provider, an origin that provides video. And this is like a bit like Richard had a bit of an architecture overview of what there is. XMB is a standardized interface. Then there's a bunch of network functions that are collectively called the broadcast core. If you're familiar with the Evolve packet core from LTE, pretty much the only thing that's going to ring a bell is MME, because the rest of those functions were added to support multimedia broadcast, multicast services. I'm not going to go into detail, there's no time. Then again, three standardized interfaces that hook up the broadcast core to the modulator, or eNode B, as it would be called in LTE. And this outputs digital IQ data, where it goes into an exciter or an amplifier. Sorry, cat problem here. And the RF gets amplified and goes out the transmitter antenna. So that's the sending and transmitting side of the whole thing. On the receiving side, we have reception on mobile. So that needs an application that contains a player. It needs some sort of middleware, and it needs support in the phone's baseband. And it should also work for stationary reception. So kind of a similar story here. You'll need some sort of modem capable of understanding your waveform. You need some middleware and some application. So that's the framework we need. And okay, now going pretty much directly to the open source reference tools aspect of the whole thing. And to make already complicated slide even more complicated, this is going to be kind of chronological. So now we're in 2020, and what is available is Rohde and Schwarz have implemented a transmitter and a broadcast core. But on the receiver side, there's only one thing available from the Technical University Braunschweig that's kind of hard to get and big and expensive. And so a big shout out to ORS, the Austrian Broadcasting Services here, because they decided to fund an open source development project to make a receiver for 5G broadcast. And this has become the basis of the 5G-MAG reference tools. So starting with stationary reception, because that's the thing that got developed first, we made something called an RT-MBMS modem, which is a bit of a misnomer because it's really just a DEM without the MO. But it can use an SDR to receive the signal that the Rohde and Schwarz transmitter puts out and decode it. And it outputs to the RT-MBMS middleware, which is the middleware stack. It kind of corresponds to the network functions in the broadcast core. It can understand its service announcement. It knows how to decode the flute encoded files and so on. And there's a web user interface that works with those two and also contains players. I'll have a separate slide on that later, I think. Okay, and now then we had that, and we started working on the transmission side because we also want open source capability there. So, okay, for a content provider, this is pretty easy. We just use FFmpeg. This stuff, BMSC, MME, MCE, we just don't have. But the MBMS gateway that exists as part of SRS RAN, or SRS LTE as it was called originally. So this is a gateway that can frame the packets correctly for the M1 interface that goes into the modulator. And we can use FFmpeg to send RTP into it directly, or we use another open source project that's part of the 5G-MAG reference tools, which implements flute encoding and decoding. Okay. Using that, we also have something now available for the modulator, which is called RT-MBMS-TX. So that's the transmitter. It implements an eNode B. It also uses physical layer stuff from SRS RAN that was modified with all those new numerologies to make the frames work for 5G broadcast. As an exciter, we can just use an SDR. Pretty much anything you have lying around, because it uses SOAP SDR as an interface. The amplifier, we just skip and we output directly. And so now we have a complete end-to-end transmission with open source tools of 5G broadcast. And to celebrate, we can play our favorite open source video. Okay, so that's stationary reception sorted. It also works for mobile reception now, because Qualcomm has done something really cool in that they not only have Qualcomm research devices available, but they also enabled existing off-the-shelf OnePlus phones to be modified to work with 5G broadcast. So there's a link for that later. If you're interested, you pretty much just go to the store, buy a phone, get ORS or someone else to modify it so that the baseband software gets updated for seamless receive-only operation. And then you can use another brand new open source project in the reference tools, which is RT-MBMS middleware Android, to actually have a full stack for 5G broadcast reception on an actual mobile phone. Okay, this is the web user interface I mentioned. Just, oh God, I'm running out of time, ain't I? Quickly go through that. Yeah, it interfaces to those processes. It shows the middleware file list. It contains HLS and dash players. It also supports service continuity in the sense of it can seamlessly switch between over-the-top broad unicast content delivery and broadcast content delivery. I'm not going to explain that either. And super quickly, emergency warnings, that's something that's coming up. There's a new project for it. You've probably all seen those on your phone. Sometimes they pop up. This is something that also BNOs can now do. They can reach phones directly, not just the MNOs. So this is a very interesting use case. And there's a project in 5G-MAG to get this into the open source reference tools. Another new thing, there's been proposals for adding time and frequency interleaving to increase the robustness of the signal. The report for that was just completed. And it's going to be added to RTMBMS modem next year, hopefully. And yeah, what's that about? Okay, you all know what a single frequency network is. I'm not going to explain that either, but it also opens up an interesting use case that's also kind of on the roadmap for me for the RTMBMS modem for next year. Because what it means that since you have 3 different exciters or transmitters here, they all use different cell acquisition subframes. So you can use these and also special reference signals to enable localization of your UE in the, so you triangulate between those signals and you measure the distances. And you can do something that will allow pretty precise localization even when GPS is down. There was a trial by the European Space Agency the previous year. That's also was based on the RT-MBMS modem reference tools implementation, and it showed pretty promising results. So maybe we can continue with that together with Rode and Schwarz next year. Okay, this is just lots of links. I'm posting the slides, so you can click on those and find all the repos. There's also a wiki that has a getting started information if you want to set this up. And there's also a link if you want to get one of those CRDs configured on where and how to do that. Owen, how am I on time? I don't know.
Well, you're over time,
Sorry,
but
I'm done.
there is just...
Thank you.
Thanks, Klaus.